Hello and welcome back to another Fluke Friday. It is episode 15 and today I have something a little bit older than I used to have, and it is from the late 60s, early 70s. The manual is from 69 and there has been a few revisions for 71, 72, so we are really in that era. And it is the 893A, a differential AC-DC differential meter. I have here the portable version, which is the normal 893A, but there is also an AR version, and that's a 19-inch for in the lab, but we have here the portable one. So the 893A AC/DC differential voltage meter, it has been calibrated in 87. It is a while back. Well, it has a stand, it goes. It does have the feet still, that is also unique. And if we look in the back, it is this same, it is made in Holland even. And it has this weird plug that HP also has on his old equipment. And I think it's the PH163. And yeah, well, okay, I have one cable that I use for all my equipment. Yeah. So this is the portable one. Well, let's see what works, what doesn't work. So, and it has two modes. So the DC mode and the AC mode. And here it is the normal voltage meter, and or if you want to use it in differential mode, because it is a differential meter, you set here the voltage that you more or less are. Then you set it here to the correct range to correspond with this. And I'm kind of smart, because if I switch here the range, you see here the dot is in front. So if I'm in 1 volt here, it means you are in 1 volt total. So here I am now in point, that's why you see the white dot here, 0.893. But if I go to 10, you can see the dot is now here. It starts moving. If I go to 100 volts, it goes here, and if I go to 1000 volt, it goes here. And I think it is from a few microvolts all the way up to 1100 volts in DC, and from 1 millivolt AC, I think, to all the way up to 11 as well. Let's just first try the TVM mode, just the normal multimeter mode. Maximum 1 volt. In TVM mode it doesn't do anything, because this is for the differential that we don't have. So let me put it here. It is a little bit dirty, but I like to see what it does. You can see the meter already is going up and down, up and down. And because it is very high impedance, I think it's 1990 mega ohm. And let me just get 100 millivolts. So I'm now to 100 millis, and you can see here that it goes to the 1. So that means it still works. So if I go a little bit higher, 200 millivolts, 400, yes, 5, 6, 8, all the way up. So this is just a normal readout. So let's go to the 10 volts then. It points to 1. Let's go to 5 volts. You see the readout is spot on actually. And what about the differential mode? Then I think I just leave this one here on 5 volts. Then let me put this one to 5, 0, 0, 0, And then, well, let me set it. Okay, 5. It thinks it is exactly 5 volt, but that is for 1 here. So I go then a little bit more precise to the middle, a little bit more precise to the middle, and then I can fine tune this. No, it thinks it is exactly 5 volt. That doesn't make sense. Let me go to 4.9 then. 4.9. Okay. It says I need to go down a little bit because it points to the. So then I go down. Let me go to 4. I'm too high. I need to go up. I need to go up. 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 And now the scale doesn't work that well, so we go more, more, more. Ooh, that's too much. It's too much. The meter is still spot on. This is unbelievable. Look, 4.9, and it says 4.900 with a precision of 0.01, 001 even. Well, it seems now to work very good, and I'm amazed how far behind the comma you can actually read your numbers now with an analog meter just by using the differential. And then you just put your meter to the middle, and now it just looks too simple because we actually know what we are reading, and these new digital ones are quite precise already, so it's easy to put them on the correct number. But what if we don't know the precise number and I just put it on my other power supply? So I'm just getting this one, and it is just on the value that it is, and I leave it first in the just in the TVM mode first. Okay, I think we can see both now. So let me just put it in the 10 volts. Now it's higher than 10, so I need to go to 100 volts. And it says it is below 20. Yeah, this is not much of a readout like this. But let me then put it here also to 20. The dot is here. Now it thinks I almost need to go to 20. What is this? No, it says 10 here. Okay, no, then we go to 2. That's a pity. So the 100 scale is not good. What about? Okay, let's go below 10 then. Maybe the 10 volts works then. So it seems that the source, internal source, above 10 volt is not good because it thinks we are here around the. So if I go to first the TVM, okay, it thinks indeed it is 9, so let's put this one to 9. Okay, then here, a little bit higher. Yes. and just look for the middle. Okay, so the voltage is 9.134. Let's see if that is the case. Just get another Fluke then. So, oh yeah, the numbers will stay in the display, so that is good. It will now go crazy probably. No, okay. 913. It even has an extra digit here. Okay, well, I want that extra digit also here. So let's get the Brayman. And what does the Brayman think? Yeah, 9.134. 9134. Look at that. Wow, that is amazing accurate. My 87.3 could not even have that extra digit. And then I took my Brayman and it is exactly 9134. That is amazing. It says 9134. It just got it spot on. And the only thing is that I found that 100 volt setting doesn't work, and the 1000 volt I still need to test. But it looks like that generator inside, because with the differential meter, of course, it needs to generate internally the same voltage to compensate for the voltage that you're measuring, and like that, it's kind of a bridge. Like that, you need to get it to zero. So if that internal voltage doesn't go up to the voltage that it should be, and it seems that it only goes to this 23 volts, I cannot go much higher than that, because it doesn't make sense anymore in the bridge. And for the 1000 volt, probably the same. So it doesn't have an output, but if you somehow can get this from this compare bridge, then you have a very accurate voltage source if we get these settings to work, but at least up to 10 volts if I can output that signal, because that's actually what you're doing now. You're comparing it with something that you're measuring. So that would be interesting. Let's see if the TVM function does work with 100 volts and with 1000 volts. So in normal TVM mode, 9 volts, 9 volts, makes sense. Power up this one. Here we can go up to, I think, 60 volts if I put them in series mode. So let's try that. So put this one first in the 100. Then let's see. I want this a little bit faster. 32 volts, yes. Second channel also 32 volts. Put it in series. Okay. I should have 60 volts. Yes, it is. It looks like exactly 60 even. And well, we cannot adjust too much, but if I then say here 60, and I put it to, no, I'm too high at things. I don't think it generates enough. It thinks now I'm on yes, it thinks it's on 107 volts. Also the double, that's more or less what we also saw in the 13 volts. It thought it was like 23, so that was also almost double. So maybe there is just that the generator only goes up to 50 volts internally. So there is something wrong there. We get half the power. What about the other scale here? Does it go to 0.6? 2000 volt. Doesn't seem it measured at all. Because it should go to half. Let's get some serious voltage. Okay, that needs to warm up a bit. I'm in the 100 volt scale. Here I'm also in the 100. Let's put it then to, let's see, 100 volts. Okay, I think I have some dirty switches because now it suddenly started to work again. So 100 volts there, 100 volts on the scale. So if I go now to 1000, it should go to the 1. Yeah, the 1000 scale doesn't work. And now the 100 is also again not good. So these switches I need to clean first. Well, okay, before I think the internal generator is broken and all these things, because we could also see that sometimes the 100 range did work and the 1000 didn't, and then again the 100 didn't work anymore. So I really think we need to take a look at the switches. So cleaning those will be my first, and well, let's open it. We're gonna open it anyway. So let's see what is in this treasure. Wow. Okay, that looks impressive. A lot of potential meters, I think. A lot of pots. So that is all for calibrating. The switches go from here is a stick and it goes all the way to the back. I think that's on off. Yeah. All these mechanical things that they have in this old equipment. Because they want a power switch here in the back close to the transformer, so then they do that. And they just put a long stick. I set the caution high voltage because if it can go up to 11 volts, 1100 volts, then it also internally need to generate 1100 volts. Actually, inside the cover, there is more. You can see exactly what is for what. So the bottom, yeah, here we also have some stuff. This is the Kelvin Furley voltage divider, and all the switches seem to go there. Those decade switches, and while they are moving, they are also far in the back. It's at least 5 centimeters, and that also has to do because there is a lot of mechanics. Because you can see the dot when we change through the ranges, you could see that the dot changes, so they all kind of moving. Lots of stuff also. Maybe we can have a better look at that. Let me keep the right stuff with the right stuff. Yeah, here we can see that the switches are really that long and they are moving a bit, so I don't know if I can tighten this a bit more or it is just the it seems to be the movement in the locking system. Well, maybe I can tighten that a bit more so the wires don't break, and I can put clean behind that. This is the pot, and let's have a look at the mechanical stuff, how the dot moves. Well, here we look behind the switches, and that is where the numbers are, and that's just with discs with the numbers displayed on it. So maybe we can move it a little bit to the back. This is internal hex, So maybe we can just lose it and then move it to the back, clean a little bit the disk, move it back, but we need to remember where the number was. And the other switch, that is there all the way in the bottom, it is moving all kinds of things. Maybe this angle shows better. So I'm moving here the 1, the 10, the 100 and the 1000, and that makes the dot move. And you see here that they're sliding some plates. All mechanical. Well, here also more mechanical. This is also one of these switches, and you see that it is moving a lot here also, even when it's not switching yet. And maybe we have some wires that are broken, because if it moves for years and years, it's more than 50 years old, maybe a wire broke, and that is maybe the reason why some of the ranges don't work. And I did not notice before, but also this terminal is bent, so it probably fell on the floor, or look. So maybe I can bend that back. So that takes a lot more time than expected. Just opening it, one I needed to drill out because the hex inside was just completely gone. It was already around, somebody used the wrong tool. But I got it loose, and I was able to clean it a little bit. I was able to clean it with the buttons off. I got a little bit in between the numbers and the front. I couldn't take it out completely because it is all connected, and I didn't want to damage it, and it is just too much connected. So I cleaned it like this. I need to clean a bit more here, but it starts to look good already. So that's it for today. We're going to finish it in the next Fluke Friday. Thank you for watching, and hope to see you next time.